Alright, so I have this problem and I'm gonna solve it. So to solve this antiderivative problem, or maybe this integral problem, what I'm gonna do is I'm gonna split this into two. Okay, so let me actually write it into two integrals where the first part is this and the other part is antiderivative x prime dt. So here what we should take notice of is x is a function of t. Okay, and then x prime prime is the second derivative of x with respect to t, and x prime is the first derivative of x with respect to t. So the first thing I want to do is first pick the first part of our integral, try to do that, and put it in a different place. Right, so what I'm going to do, I'm going to use a u sub here, a u substitution, that's what I mean. So if I let u to equal to x prime, then du dt, that's what I'm going to look for, is equal to, so you can actually look at it this way, x prime prime dt. That's how you du dt is going to look at, or du dt is going to be x prime prime. I mean, derivative of x with respect to t again, but here we have x prime already. So if I find the derivative of s prime with respect to t, I'm going to get s prime prime dt. So what this whole thing is going to do is that I can look at a place. This can be written as x prime prime dt, right? So the place I see s prime prime dt, I'm going to put du there. Or if you are familiar with making the t the subject, you can make the t to be equal to du over x prime prime, put the t here, and then whatever I'm going to get, you're going to get the same thing. So based on what I've said here, this integral is going to be untidy. I'm not going to write a bounds here because ideally I'm supposed to change the bounds to the u bounds, but I'm not going to do that. Okay, you can, if you want, you can actually change it. So I'm going to write this as x prime here is u, and then s prime prime dt is actually du, right? So if I perform this antiderivative, I'm going to get u squared over 2, and because we had a bound, then I'm going to write the original thing with it bounds here, and then this is going to be u is x prime, so I'm going to have x prime squared over 2, then evaluated at 0 to t. And this, if I perform the evaluation, x prime, I mean squared, right? So I'm going to have 1/2 x prime is what, with respect to t, is dx dt squared, and I'm going to evaluate this from 0 to t. This, after evaluation, is going to look like this. First of all, I perform my evaluation at t, so it's going to be 1/2 in bracket. When I perform it at t, it's going to be d of x dt, evaluate this at t equals t, right? And then I'm going to square this term, and minus d of x, or maybe you can actually, to be more precise, so this is how the formal definition is. So to be more precise and save space, how this will look like would be like so let me first rewrite this guy as how it is, x prime. So x prime evaluated at t, that's what it means, right? T equals t, so just t, and then you square that, minus x prime evaluated at t equals 0, right? So it's going to be 0, and then you square that, and that is the evaluation for that term. Okay, so in other words, you are evaluating x prime at the point where t equals t. That's what this means. And then this one is at the point where t equals 0. That's why I have this s prime of t, then square it, and the rest. Okay, so if you know s prime of t, you just square it and put it here. But at the moment, we don't have the s prime of t, so that is the solution to, or maybe the antiderivative to the first part. Now the next thing to do is to look at the second part, and I'm going to do it here. The antiderivative x prime dt and here too I'm going to use a u sub where u equals x of t, and then my du is going to be x prime dt. So where I see x prime dt, I'm going to put it the u there. So this is going to look like antiderivative u, because u is x and s prime dt is du. This is going to be u squared over 2. So what this means is our whole antiderivative thing here with a bounds, now put it there, because I usually don't like to play with changing the bounds. If you want, you can change it. If you don't, just keep it like I'm doing here. And x prime or x prime dt is equal to u is x, so I have x squared over 2, then evaluate this as 0 and then t. So this is gonna be x is equal to x of t, right? So this is gonna be 1/2, again the same thing that you did for this, x of t, or x evaluated at t, then you square it, minus x evaluated at 0, then you square it. And that is the solution to that. Okay, so what you're gonna do, the final solution to everything, which I'm gonna write at the latter part of this whole thing, is that the final solution is supposed to be antiderivative 0 to t x prime prime x prime plus x prime dt should be equal to 1/2, because this also has 1/2, this has 1/2, so I'm going to pull it out. Then this guy is x prime of t, and then you square it, minus x prime of 0, you square that, plus x of t, you square that, minus x of 0, and you square that. The problem to this question is that do not assume that x prime of 0 is 0 or x of 0 is 0. You don't know x of t yet, so you cannot just assume that. Okay, so if you want more, if you don't write it in a more simplified version or form, you can actually try to write it this way, then you square that. Maybe you can just do it like that. Okay, but you know that it's just the whole s prime of t, and then you are squaring it. Okay, plus x of t, then you square that, or maybe s squared of t. I think that should work rather. Okay, or maybe just notice that this whole thing is, I'm writing it back so that you don't get confused. Minus x prime of 0 squared, and then minus x of 0 square that, and that is the solution to that problem. Okay, so that was just a fun fact I wanted to solve with you. See you in our next lesson.